Alright, so section 1, matter and substances. This is our first section in the chemistry of life, our first unit in our life sciences section. Our main unit objective is the state standard B2.2a. We're going to go through a warm-up, we'll go through the key ideas, we'll look at atoms, chemical bonds, polarity, and then we'll summarize the overall lesson. So our warm-up for today, what is the difference between an element and a compound? And it's my goal that by the time we get to the end of this unit, you will have a good understanding of the difference between an element and a compound. So our key ideas for this section: what makes up matter, why do atoms form bonds, and what are some important interactions between substances and living things. Kind of the important thing there is seeing the different materials that make up all living things and how they pertain to us being able to go through our daily lives and successfully complete the physiological events that occur inside of our bodies. Atoms. I'm hoping that this section will be a little bit of review for you from last year, from 7th grade science. Atoms are made up in every living thing, or I guess I should say they make up every living thing. Matter is anything that has mass and takes up space, and matter is all made up of different forms of atoms. All matter is made up of very small particles called atoms. An atom is the smallest unit of matter that cannot be broken down any further by any chemical means. There are parts of atoms called subatomic particles, being the proton, the neutron, and the electron. Those things are smaller than an atom. They make up an atom. The important part here is this cannot be broken down by chemical means. An atom has a positively charged core, and it is also surrounded by a negatively charged region, and we'll get into what makes up that positively charged core and what also makes up that negatively charged region around the outside of the core. So this picture is an illustration of an atom. It shows the central region of the atom being the nucleus, and then there's electron energy levels around the nucleus. This is called the electron cloud. This area is the area in which all electrons orbit around the nucleus. So the nucleus is positively charged. It's made up of positively charged protons and neutral charged neutrons. So there's no charge to neutrons. They are neither positive nor negative. And then the negatively charged electrons, they circle around the nucleus in this area called the electron cloud. The electron cloud makes up that negative charge that occurs in atoms. The important thing to point out here is that the negative charge, a lot of times in stable atoms, is counteracted by the positive charge of the nucleus. So elements. An element is a substance that's made up of the same number of protons. So it's an atom that has the same number of protons. For example, all elements of carbon have 6 protons. Atoms of an element may have different numbers of neutrons, however. Anytime we have an atom that has a different number of neutrons, it's called an isotope. So for example, carbon always has 6 protons, but carbon in different forms can have 5 neutrons or 7 neutrons, or it can also have 6 neutrons. So we need to understand the isotopes occur where the number of neutrons can also change. Chemical bonds. An electron cloud of an atom may have different energy levels. further in this section, or in this unit I guess I should say, we'll go over what many of those different energy levels are. Electrons in the outermost level are called valence electrons. And typically atoms want to combine with other atoms so that that valence shell ends up with 8 electrons in it. And in that case it causes them to be stable. When atoms combine, a force called a chemical bond holds those atoms together. Chemical bonds form between groups of atoms because most atoms become stable when they have 8 electrons in the outer shell, in that valence shell, as I previously mentioned. When atoms of different elements combine, a compound forms. So a compound is a substance made of the bonded atoms of 2 or more elements. So if we have 2 or more elements attached together, we would call that a compound, not an element. We're combining many different types of elements together, we form a compound. A covalent bond. A covalent bond is a bond that forms between atoms where they share valence electrons. So 2 atoms combine together and they're sharing those outermost electrons. A molecule is a group of atoms held together by covalent bonds. So there's lots of examples of substances that occur, or molecules that occur, due to covalent bonding. One example is a water molecule, H2O. It forms when an oxygen atom forms covalent bonds with 2 hydrogen atoms. On the next slide I've got a short little video. It'll kind of help you get a visual representation of this covalent bonding.
Many atoms form covalent bonds. In covalent bonds, electrons are shared by both atoms. The first energy level in atoms can hold 2 electrons. By sharing electrons in a covalent bond, each hydrogen atom has a full outermost energy level. Water molecules are also held together with covalent bonds. Again, we see that covalent bonding gives each atom a full outermost energy level. The outermost energy level for hydrogen can hold 2 electrons. The outermost energy level for the oxygen can hold 8 electrons. In covalent bonds, the shared electrons move between the atoms that share them, forming a single electron cloud around both atoms.
The next type of bonding that I'd like to talk about is ionic bonding. Typically atoms can have or give away charges. Electrons, in this case, would be an example of that. So atoms can achieve stable valence levels by losing or gaining electrons. This causes atoms to either have a positive or a negative charge. If an atom is giving away an electron, then it's probably going to have a positive charge because it's giving away part of its negative charge. Okay? If it gains an electron, then it's going to gain a negative charge. So in this case, it would be an example of an atom that may have a negative charge. When we have 2 atoms that have different charges, those atoms want to come together, much like magnets do. Magnets have a positive end and a negative end. Atoms work very much similar. If you have 2 atoms that have opposite charges, they may attract one another and create what's called an ionic bond. On the next slide, I have a video that gives a visual representation of ionic bonding.
An ion is an atom, radical, or molecule that has gained or lost 1 or more electrons and has a negative or positive charge. For example, when a sodium atom loses an electron, it becomes a sodium ion. Sodium ions have a positive charge. Other atoms become ions by gaining an electron. For example, When a chlorine atom gains an electron, it becomes a chloride ion. Chloride ions have a negative charge.
Alright, so looking at ionic bonding, and specifically we're going to look at simply table salt. Table salt is a combination of sodium and chlorine atoms. So this first section of the slide right here, a sodium atom loses an electron to a chlorine atom. So sodium gives up an electron. Each atom becomes a stable charged ion. So you'll notice sodium is now positively charged because it gave up an electron. Chlorine is now negatively charged because it gained an electron. Remember that protons are positively charged, electrons are negatively charged, and neutrons do not have a charge. The attraction of the oppositely charged ions forms an ionic bond. So we've got the positive charge of sodium, the negative charge of chlorine. Because of those two charges, the atoms want to combine together, and they form table salt. And table salt is when several ions interact together to form salt crystals. Polarity. In some covalent bonds, the shared electrons are attracted more strongly to one atom than to the other. Due to this, we end up with one end of a molecule that has a partial negative charge, while the opposite end has a partial positive charge. Molecules with partial charges on opposite ends are said to be polar. This idea of polarity leads into our next section on solubility. The partially charged ends of polar molecules attract opposite charges. Due to this behavior, polar molecules can dissolve other polar molecules and ionic compounds. So for example, water can dissolve sugar and salt. Any substances that would not be polar or non-polar substances. For example, oil, grease, and wax. Because those materials are non-polar, they do not dissolve well in water, which is polar. And the next slide gives a visual representation of solubility in water. And in this case, we're looking at the solubility of table salt in water. You'll notice that, again, chloride has a negative charge. Sodium has a positive charge. When this substance is added to water, those materials want to bind with the water. So water dissolves ionic compounds. When sodium chloride, NaCl, is dissolved in water, sodium ions, Na, and chloride ions, Cl, become surrounded by water molecules. Remember, water is H2O. The last type of bonding that I want to talk about is hydrogen bonds. So when bonded to an oxygen, nitrogen, or fluorine atom, a hydrogen atom has a partial charge nearly the same as a proton's charge. It attracts the negative pole of other nearby molecules. This attraction is called hydrogen bonding, and it is stronger than attractions between other molecules, but it's not quite as strong as covalent bonding. Hydrogen bonding plays a very important role in many of the molecules that make up living things. Many of the reactions that occur within your body are due to hydrogen bonding. Water molecules bind together with other water molecules in this process of hydrogen bonding. one end of a water molecule has a negative charge, while the other end of the water molecule has a positive charge. The negative charge and the positive charge want to come together. This allows water to easily attract other water molecules. Remember that we said on the last slide, though, hydrogen bonding is not as strong as covalent bonding. So hydrogen bonds can be broken fairly easily. This allows water to flow and move around with other water molecules. So our summary, our main points for this section: all matter is made up of atoms. An atom has a positively charged nucleus surrounded by a negatively charged electron cloud. And also remember that the parts that make up atoms, the proton, the neutron, and the electron, all have their own charges. A proton being a positive charge, an electron being a negative charge, and a neutron not positive or negative. Chemical bonds form between groups of atoms because most atoms become stable when they have 8 electrons in the valence shell. Any atom that does not have 8 electrons in the valence shell wants to gain electrons until it gets 8. Polar attractions and hydrogen bonds are forces that play an important role in many of the molecules that make up living things. And this is kind of the major point for us as we transition into life science. These polar attractions and these hydrogen bonds are exceptionally important in the life processes that you go through on a daily basis in order to survive.